Good morning, everybody. Good morning. Uh, so yesterday we were talking about we had talked about the communication diagram and how the collaboration or communication diagram is converted into methods, right? Then we also talked about the constraints or the conditions which you apply in your program, right? So So now the next part, this is your fourth block. So the next part is implementing state charts. So in the previous example, we were talking about the implementation of the constraints. In this section, we will be describe how to convert state chart into executable code in object-oriented language like Java. So you are already aware that the object model defines objects, attributes, and links between them. The attribute values and links detained by objects are known as its state. So when one object communicates with another, the communication result of these objects is in the form of events. Events are external or internal features influencing the system. So they are talking about what is a state, what is an event, right? In a state chart diagram. So the attribute values and links obtained by objects are known as state, its state. When one object communicates with another, the communication result of these objects is in the form of events, and events are external or internal features influencing the system. The state chart or diagram represents the combination of states, events, and transition relationship between two states. Transition is relationship between two states. So this diagram is used in dynamic modeling to define a class dynamic behavior. The dynamic model contains multiple state charts and one for each class, right? The following state diagram for booking tickets is shown. So you have to make a state chart diagram. So they are saying that the dynamic model contains multiple state charts and one for each class. So one for each class or one for each process, you can make a state chart, like they are showing you a state chart diagram of how to book a ticket. So your starting is this, right? So first thing is authentication. So if yeah, instead of authentication, you can also write login, right? So if login is successful, right? If login is successful, so you will be going to seat availability check. If login is not successful, you go back again to the same process, that is login. So they have written authentication, you can write login also, right? If it is invalid login, you will go back to authentication only. Otherwise, you will enter so you will enter ticket details. You will enter the ticket details and you will go to the next thing, that is seat availability check. Then in the seat availability check, you will give the passenger details. You will enter the passenger details and you will book the booking ticket. For booking the ticket, you will make the payment. So you will go to the payment option. If the payment is successful, your ticket is printed. If it is not successful, then you will go back to the payment again, right? Make payment again. So if it is successful, ticket printing, and then you log out. Stop, right? So this is a state chart diagram for booking ticket. The UML state chart diagram is used to designate the behavior of a particular class. This diagram can be included only at the class level. A class can have either a state chart or an activity diagram, but cannot have both together. While defining the states, you can ignore those attributes that do not affect the object's behavior. Some classes do not practice state charts since their objects are uni-state and they always behave in the same manner. Right. So you have initial state. This is starting state one, state two. Some transition is happening, and you are changing your state. Something like that. A simple format they are talking about. So to implement start using switch statement. Now you know what is a switch statement. Everybody knows that. For condition or decision making, you have if and switch, right? So in this section describes the switch statement approach for implementing state charts. The states of state chart diagrams are denoted as objects or scalar variables. Events are and actions are indicated as methods. The most basic technique to implement state chart is the switch statement. You may be aware of the functionality of a switch statement in Java, where a switch statement executes one statement from multiple case statements depending upon the condition. It is based on the current active state and control transfer to the code for processing the event. It is just like an if else if ladder statement. Each case clause of the switch statement denotes a single state of the object and implement the various action and activities for the specific state. The actions are implemented as a simple statement. The behavior of the state chart is placed in a single class. States are denoted as data values. A single scalar variable is a state variable that stores the current active state. The state variable is used inside each event method of the context class. The right case is chosen on the value of the state variable. The implementation strategy is simple, but it has drawbacks also. In the case of the addition of a new state in state chart, this approach does not allow flexibility in the code. There is code duplicacy in many places, and the reuse of code is very difficult. So they are saying that you can implement such a kind of a thing with switch statement. So like here, you can use that for login. You can say that if login is successful, you will do that. If login is successful, so if also can be used here. So something like that. So you can use switch, or if multiple conditions are there, you can use switch statement. So that is what they are saying. But they are saying if you have a new state added in your state chart, right? So this approach does not allow flexibility because the code flexibility is not there, and reusability will not be there. It will be duplicacy in many places. So implementing state chart using helper object. Due to the redundant code problem in the switch statement, the notion of a helper object is introduced. This is an alternative object-oriented approach to the switch statement. It places each case clause of a switch statement in a separate object. It provides a natural way to implementation of the state chart diagram. It removes the code redundancy and builds reusable code. Right. So helper object denotes the current state of the domain object and specifically implements the behavior of the current state. So the domain object transfers all the external messages to its helper object, which reacts to the messages on account of the domain object. The helper object signifies only one state of the domain object. The methods of the helper object do not enclose conditional statements and are very simple ways to implement. Whenever changes occur in the state of the domain object, a new helper object is created, which interchanges the older current state and implements the behavior defined in the new state. The reference to the helper object is recognized as the current state in the domain class. So the state chart shows the behavior of the class, which is a super context or domain class. During this implementation, an abstract state class is created, which describes the interface for capturing the behavior connected with the states of the state chart. Each state turns into a derived class from the abstract state class. Each transition transforms into a method in the corresponding state class to provide an appropriate way of invoking services on the context object. Each action in state chart will be a method in the context class which contains a reference of the current state in the state object and offers all events for processing to the current state object. So they are giving an example. Consider the following state chart diagram shown in figure 13.10 for the video player application with two states, stop and play. Right. In the stop state, when a user presses a play button, then play button event happens and the device executes the play start action and goes to play state. In the play state, when the user presses a stop button, the stop button event generates and the device executes the play stop action and goes to the stop state. So they are giving you a state chart diagram of a video player which has two states, stop and play. So if you press in the stop state, when a user presses the play button, so first you are in the stop state, and when user presses the play button event happens and the device executes the play start action and goes to play state. In the play state, if you are in the play state, when the user presses a stop button, the stop button event generates and the device executes the play stop action and goes to the stop state. So while implementing the state chart as shown in figure 13.10, there are four classes: video player, player state, stop and play. So the video player is super context class and player state is an abstract state class. Right. The two classes such as stop and play which implement the behavior specific to the stop and play state respectively, and they are subclasses of the player state class which offers a common interface for all the state classes. Right. So these classes are called state classes since they implement individual states of the state chart involved in the domain class. So this player state will be your abstract state class, will be your parent, and two derived classes or the child classes will be stop and play. They are subclasses of player state class. So this will be your parent class, and these are the two child classes. So they have a common interface for all the this, right? So like they are showing state chart for a video player. So this is your start. So first you are in a stop state. So if you press a stop button, if you press stop button when you are start button, sorry, start, if you press the start button, so here what they have said, if you when a user presses the play button, start button means play button, right? So the play button event happens and the device executes the play start. It is executing the play start action and goes to the play state. It will go to the play state then. When it is playing and you press the stop button, right? So when it is in the play state and when the user presses the stop button event generates and the device will do the play stop action, right? Execute the play stop action and goes to the stop state. So it will go back to the stop state. This kind of a thing. So these state classes have a reference to the domain object and name it as vPlayer as mentioned in the program. So these state classes have a reference to the domain object and name it as vPlayer. So for the domain object, their reference is made as vPlayer. So in brief, each state in the state chart diagram turns into a class, and each transition from that state becomes a method in the corresponding class, and all actions become methods in the domain class. So the domain object forwards all incoming messages to its current state object, and which is mentioned in the program code under the name of PS. So the behavior of the above state chart diagram can be implemented in Java as follows. So class video player is there. So you have these classes: video player, player state, stop and play. So video player class is there. So uh, here player state. So player state is this your abstract class. This is your player state class, right? So this is your abstract state class. So here in the video player, you have made a player state PS, the helper object. You have created the domain object, domain class object you have created. This is the class which is there, player state. So PS is the object you have created. Then video player is a constructor. PS is equal to new stop this. So a new object of stop they have created for this object. Void stop button, PS dot stop button, void play button, PS dot play button. So this will stop the. This will be the stop button. This is the play button. If you press the buttons or methods, you call it void play start, void play stop. So this is these are the other methods which are there. So this is the start and stop, right? These are the buttons and these are the actions. So if you press the button, this will be called. If you and when the stop button is pressed, so play stop action will be performed. When play button is pressed, so play start action will be performed. So these are the methods they have created in the video player, and in the player state, video player v player. This is a reference to domain object. So your this video player object is also created here. This is reference to the domain object, right? And this is the helper object of this class in this, and this class object in this, right? Then player state video player VP. So this is a constructor of this player state, and you are passing the object of this video player class VP. V player is equal to VP. You are saying will be the value from here passing here. So it will be equal to this reference object. Void stop button, void play button. So this is a stop button you are making here, and play button you are making without any, what you say, body, right? Because it's an abstract class, right? Then here you have two subclasses of the player state class, that is class stop extends player state. So this is a child class of this, right? So stop video player VP. So you are making the constructor for this stop class, and you are passing the video player this video player's object to the constructor super VP. So this is a super uh, class video player, they are saying, right? Video void play button. In the play button, this play button v player uh, dot play start. So v player is this object from the parent, because the parent class of this is stop is player, so you can access this v player. So v player dot play start. So this play start object is starting here, action is starting here. V player dot ps is equal to new play v player. So you are initializing this, you are making another object here. This kind of a thing is kept in the stop. But the stop is calling this action uh, play start, right? If you press the play button, it will start the play start action. And in the play button with play class, which is an extension of again the player state, this is a subclass of player state. Play video player VP, again you are passing to the constructor the object of the this, and this, that is a super you are creating. Void stop button method you are taking, and v player dot play stop action you are calling. V player dot ps is equal to new stop v player. So this is you are initializing. So this kind of a thing they have created from this state chart diagram, that when you press the start button, when you will press the start button, right? So you are initially at the stop, and you press the play button. So it will call the play. After pressing the play button, it will call the play start action. So it will play whatever is in the video player, right? If and when you are playing, you are in the play state. So if you press the stop button, right? If you press the stop button, it will call the play stop action, and you will go back to the stop state. This is what they are showing here in the code. So this is what they are talking about, how to convert a state chart diagram into code. That is what they are talking about, right? But that will not be asked, but this is what how you can convert it into a code in your thing, right? So that was in for the state chart. Now they are talking about persistency. So this question can also be asked in your theory exam. So in general meaning, persistent means preservation, preserve, right? It occurs over a prolonged period. This section describes the persistency in terms of object oriented approach. So an object resides in a memory space and survives for a specific period of time. So in traditional programming, the life of an object is usually the life of the execution of the program that created it. So in earlier programming, traditional programming, when you create an object, it used to get the period of its life is until the object, the program is running, the object is there, right? So in files or databases, the object life is longer than the duration of the process creating and using the object in a program. But in a database or in a file, you want to save the or you want to preserve that object, right? It's not that when your program is over, then your uh, object also gets destroyed. So you don't want that. You want to preserve it, you want to save it. So this property by which an object stays even after its initiator concludes, that means if you are closing your program but your objects remains in the memory, is known as persistence, permanent, right? That means you are preserving it. So persistence is important for enterprise application because it gives required access to relational databases. So basically in a database, what you are doing is you are preserving or saving the data inside the memory, right, for a prolonged period. So that is what persistence means. So data persistence, you all know that computer programs operate on data. The most important task the application performs are to save and restore data. Persistent data may give useful mechanism for passing data between programs and permits a program to resume processing after a while. So if you want data to persist after the program execution, then you must use a permanent data store. So what they are saying is that you need data after the execution of the program also sometimes, or in between intermediate results also you want for the execution of the program. So you want that the data should be saved somewhere permanently, and that is in a data store. So for that you require data persistence, right? What is process persistence? Persistence represents a lifetime of a process or an object. Referring to the computer threads and processes, a persistent process is a process which cannot be killed or shut down by other processes until the user kills them. So if you're talking about process persistence, not about data persistence is you're storing it in a data store or a database permanently, right? Process persistence is a process is a program in execution. Whatever is executing is a process. So process or thread, you can say, are those which are living until their execution is not completed. Process lives up to that. But in a persistent process is a process which cannot be killed or shut down by other processes until the user kills them. The user which is using the process, until the user kills them, until that the other processes or it cannot be shut down. So that is a process persistence. What is object persistence? In connection with data, persistence means an object should not be removed except it is actually erased. Right. So this requires appropriate storage and certain procedures which permit the data to persist. So you can store persistent data in a persistent database, appearing as long-lasting records or long-lasting objects that fluctuate within devices and software. So they are saying it is similar to persistent data, object persistent, which means that the object should not be removed. It should be until you are actually erasing it. That will remove it, and otherwise it will not be removed. It will remain in the storage permanently. That is the same object persistences. So persistent data is steady and restorable and is accessible after closing the application. So persistent data is that data which is stored in the database, and even after you close your application or your program, it is still available for you to access. So this type of data must be saved into a database or internal or external memory, whereas non-persistent data is not accessible after closing the application. And non-persistent data is known as transient data. Transient means temporary. That means until the program is running, that data is available, and when the program closes, the data will not be there. So that is transient, non-persistent data. It will not be accessible. So the non-persistent data means it is volatile data that is available during the application's execution. So that is what I'm telling you. Until the application or program is running, the non-persistent data or transient data will be available. That is volatile. That means it will be only up till the execution of the program. After the execution of the program is completed, it will not be available. For example, relational database management system store persistent data in the form of records and tables and are accessible even after closing the application. So if you are talking about databases, that is RDBMS, Relational Database Management System, it will store the persistent data, permanent data. You are storing the data in a database in the form of records or tables, right? Which are accessible even after you close the application. So identifying persistent data while designing models may not always provide a clear picture of the data, and this data should be persistent or transient. That means you should understand what data is permanent, that is persistent, and what data is temporary, that is transient, right? There are no limitations to defining permanent data in models. So a single model can bring together persistent and transient data. So actually you will not initially recognize which data is permanent and which data is transient or temporary, right? But there is no limitation also on defining, but you have to find out all the things, that whether which data will be permanent and which is temporary. The transient data are temporary in nature and do not have any representation and identifier values in the database. Transient data is stored in random access memory, that is RAM, and valid only inside a program. It is lost whenever the program terminates. So when the program terminates, the transient data also gets lost. Like in a RAM, until the RAM is running, or the system is running, the RAM is running. So the whatever is in the RAM will be running at that time. When system closes, the data in the RAM is closed until and unless you save it in a hard disk. Same way. So persistent data is saved to the database and it survives after transaction updates or program concludes. So permanent data will be available in the database even if your transaction is updated or your program has completed, it will be available in the database. Generally, persistent data is used to specify the shared access and updated databases across transaction. Right. So this is what persistence and transient means. So you should understand what is persistency, the permanency of data. Right. What is serialization? So serialization is the process of transforming an object into byte streams to store the object to memory or a database. Now, your data has to be stored in your what you called in your system or in a database in the form of bytes, right? So to transform that data, that object into byte streams and to store it in memory, object to memory or a database, is known as serialization. So serialization's main objective is to save an object state so that it recreates when needed. So they are saying that you want the main objective of serialization is to save an object state, whatever state it is right now in, whatever value the object is having, whatever thing right now, until what the execution has happened in middle, the execution was the object was in the middle of some execution, and whatever state it is right now in, right? And you have to store that object somewhere till you are doing something else. So object is stored halfway, whatever value is there, and you can recreate or you take that object from that particular state and use it. So that is what serialization does. The inverse process is known as deserialization. Inverse means the reverse, and this process is used to convert byte stream to actual data, actual Java objects in memory. So serialization means the objects are converted into byte streams and stored in the memory. And deserialization means that the byte streams which you have the objects byte stream which you have converted, the byte streams are now converted back to Java objects. Right. So the creation of the byte stream is platform independent. If you are taking an object and converting it into a byte stream, why you are doing it? In Java, Java is platform independent. Why do you say that? Because it converts the objects or it converts the data in it into byte stream. So what does it help you in? The bytes can be read in any platform, any kind of platform or any kind of system. Right. So it can be read from any kind of system. It is platform independent. So the object serialized on one platform can be deserialized on a different platform. That is what is there. So Java provides serialization with the use of serializable interface. This interface, java.io.serializable, is a marker interface which does not declare any data members and methods. Using this interface, mark the Java classes and objects of these classes may get a certain ability. When it is done, the methods write object output stream classes used for serializing an object, and read object of output input stream class is used for deserializing an object. This way, persistence can be implemented in Java. So to implement persistence, permanent serialization is used. They convert the object into byte stream, and deserialization is converting back the byte stream to back to the object, right? So it is done by write method, write object to convert it into or serializing to convert it into byte stream by the object output stream, and you can convert back to the byte stream can be converted back to object by read object. That is deserialization, right? Can you understand what is persistence and serialization? Any doubt, class? Anybody has any doubt in this?
No, madam.
Right. So these questions can be asked in your theory paper. What is persistency, or what is persistent data, and what is serialization? This can be asked. So they are asking what is the difference between persistent and transient object, right? What do you understand by data persistence? How you will make your data persistent, right? What is the difference between persistent data and non-persistent data? That is the same persistent and transient. So that is what persistent and non-persistent means. What is serialization, where it is used, and why? So if you go to your this check progress, please go to the check progress question also. From there also questions are asked. So they here, the difference between transient object, persistent object are as follows. Persistent object is an instance of a class in the domain model that represents its values in databases, whereas transient object is an instance of a class in the domain model which is created in memory. The garbage collector will remove the transient object if they don't have any use and reference in the database. The persistent objects are saved in the databases. For example, if you acquire an entity from a database, then that entity is persistent. When you create a new entity, it is transient until it is stored in a database. So that is persistent data is data which has no longer lifetime than the program that created it. Enabling data to be stored on a permanent storage medium provides persistency. So they are giving you the persistent data is accessible after closing the application. This type of data must be saved into a database or internal or external memory. Non-persistent data is not accessible after closing the application. It means that it is volatile data available during the application execution only. Serialization provides an appropriate and straightforward approach of making data persistent. Serialization transform an object into byte stream to store the object in memory or a database. It is more suitable when the amount of data included is relatively small. If more amount of data are to be stored, serialization may no longer be appropriate approach for storage. So this is what they have given you, right? So
तो
this
मैडम
is
जैसे ये हम लोग गूगल मीट में मिले हुए हैं, जैसे बात कर रहे हैं, तो इसमें जो हमारी अटेंडेंस जा रही है दैट इज नॉन परसिस्टेंट डाटा, क्योंकि जैसे ही मीट खत्म होगी ये भी डाटा गायब हो जाएगा.
nahi, you have certain things in Google Meet ki you can keep the attendance of
Yes,
the.
you can. Yes, we can keep that in, but as we can see that suppose
If
the
we are
class is
not,
going on.
if we do not have selected that option, so it is
Yes.
kind of a transient data. If you
Mm,
do not select the option for saving the attendance, so it is transient
mm,
data until the this
mm,
Google Meet is running. The attendance is
mm,
there, and if you close it, it will go off.
mm. Right.
Right? Like if we are saving the video is being
Yes.
recorded, right?
Yes.
So if you do not record the video, the whatever we are talking about will not be available to you later on.
So that is non-persistent data.
That is non persistent.
Mm, right.
Right. So serialization is a type of thing which helps you in doing making the data persistent.
Yes.
Right. So that is what they want. They are explaining. So
So
now
that is
object.
just a minute, madam.
Uh,
Suppose we are sending an email to any person. So
hmm.
that is an example of serialization, because the data is created here and then it is streamed by to another person, and then he is again downloading that email and
Yes.
opening it
Yes. It is
through
kind of
some
a
setup.
serialization.
So that is called serialization.
Yeah, you are storing that data, and later on the data, that is serialization is being done. It is stored in byte stream, and then when you open the person receives it in byte
Yes.
streams, and when the application which is opening it email application will
Mm.
convert back to the email part of that.
So for that, the tools I use that Adobe PDF and that all.
No, PDF is not there. Your email
No, no.
application has that kind of a thing,
Okay, okay. The email app,
right?
right?
Yeah,
Hmm.
mail.
Okay.
PDF is an attachment. That is another kind of a thing. I'm just saying normal
Hmm.
mail we are talking about.
Right, right, right.
Right. Now we are talking about object mapping with databases. How do you map objects now to database? So first, they are talking about the database. So first, they are talking about relational database schema for object models. So a data, what first they are talking about, what is a database? A database is a group of interconnected data files with structures. It is designed to come across the various information necessities of the organization. The database is created by using DBMS software, that is database management software. The designing of the database is the most significant task for database application software. The term relational schema describes the outline of the database. Relation schema expresses the design and structure of the relation, that is table, such as table name, set of attributes or field names. So we will be talking about all those things in this. So a DBMS, that is a software, is a software program which is used for creating, retrieving, and controlling access to permanent data. So you have the database softwares, right? Like SQL is there, right? MySQL is there, or Oracle is there, or whatever databases are there. So those are your software programs which help you for creating, retrieving, controlling access to permanent data. There are various motives for using DBMS, such as integrity, security, crash recovery, data distribution, sharing between users as well as applications. So this is the features of a DBMS. Why do you want to use DBMS? You want to create, retrieve, and control access to the data, and also you want to have integrity, security, crash recovery, data distribution, sharing also. So these are the things they are talking about. To effectively manage data using a DBMS, you should know certain terms, like what is database schema. Database schema is the design of a database. How do you design a database? It is the frame of the database that signifies the structure, table name, and their field, column name. So you're designing a data, you're creating a table. Inside the table, you have attributes or field names, and you have records or tuples which are there. So each column can hold which type of data, constraints on the data to be stored. So you can also have constraints on the data, like you can create a primary key, you can create not null key, you can create a unique key, you can create whatever different constraints are there. And if and the relationships between the tables, so you can also say that database schema is a logical structure of the database and tells us how the data are organized in a database. So it is a logical structure. Right. So that is database schema. What is data constraints? Sometimes you want to place certain restrictions on the type of data that can be inserted in column of a table. So you want that in this column only, just like address is a column or attribute. So in the address, it should be the size of the address should be 30 this, and it should not. It should be it. You can allow not null also. You can allow null also. Whatever. So some constraints you want to be applied. So those are known as certain limitations. So that are your constraints. So in other words, you can say that it is a condition which applicable on the columns. It ensures data integrity, and a few names of the constraints such as unique, primary, default, and check constraints. These are the constraints, right? Unique value, you each value should be unique, so you have unique. Primary also does that. Primary also don't take any duplicate value. It will be a unique value. And each to recognize each individual field, because if you are not set a primary key, so if you are setting name as the primary key, you do not have any enrollment number or ID or anything. So what will happen, two persons may have same name, then it will be a problem. So you don't want, the duplicacy should be there. Each record should be identified individually. To identify a record individually, a primary key should be there which should have unique values, and that is your ID or enrollment number kind of a thing. So default key is there, or check constraint is also there, so we'll talk about that later. Then data dictionary. So what is a data dictionary? The database schema, along with numerous constraints on the data, is stored in a database catalog or a dictionary. It is called as metadata. Metadata means data about data. So you have data, and the information about that data is known as a data. So all the data, the schema, the logical structure, the constraints, the data is stored, the catalog, everything is known as a dictionary or metadata. Metadata is data about the data, information about that data. So what is database design? A database design is an important and tough task for any business database application. Database design describes the database structure for use for creating, storing, and maintaining information. The main objective of designing a database is to build physical as well as logical models of the designs for the planned database system. There are two methods to design a database, that is attribute driven design, that is ADD, and entity driven design, that is EDD. So in attribute driven design, assemble a list of attributes related to the application and normalize a set of attributes that preserve functional dependencies. In contrast, in the entity driven design method, define entities which are significant to the application and explain them. Usually, database design has limited entities as compared to the attributes. Entity design is more considerable due to being easily manageable. Object modeling is a kind of entity design. So, everybody knows about ER diagram, ERD, entity relationship diagram,
Yes, madam.
right? So generally we follow entity relationship diagram, EDD, or you can say entity driven design we follow in our database design, not the attribute driven design. We follow the entity driven design. So we have entities, right? Like student and teacher. Student will have its own attribute, teacher will have its own attribute. There is a relationship between them. This kind of a system we generally make, entity relationship diagram, right? So object modeling is a kind of entity design only,
Okay.
right? So three schema structure is there. So the three schema architecture provides an abstract view of data to the users. The three schema architecture is shown here. This is your three schema. So you have the external schema, which is view 1, view 2, view 3 is external schema, then conceptual schema, then internal level. Right. So the database design contains three layers such as external, conceptual, and internal schemas. The external schema is external view which represents some portion of the entire database. So this is an external view which is seen by the user, end user. Right. It is a higher order abstraction which is seen by the user. The next level is the conceptual, which is this one, which represents data logically. It defines what data is stored really in the database. The third level is the internal schema, which shows the lowest level of abstraction and closest to physical storage. The closest to physical storage or the actual database is the internal level. Object modeling is suitable for designing both the external and conceptual schema. So when you are modeling anything, like right now, though we are modeling, right? What we are studying is modeling. We are not talking about the actual or internal schema. We are talking about the external and conceptual view, the modeling view. So the object modeling is suitable for designing both the external and conceptual schema. For this, you should construct one object model for each external schema as well as another object model for conceptual schema. That is what the main thing is. So we will not be talking about the outside thing. We are talking about the inside one, which is this one. Right. RDBMS logical data structure. So a relational database, R means relational database management system, is a database management computer program based on a relational data model. Edgar F. Codd. So Codd rules are very famous in your database. So Edgar F. Codd invents it. The relational model can store data with one or more relations. Relations are your table. So in the form of a table, in a database, you create tables, and in tables you have fields and records. You can say call attributes and tuples or records are there. A relation is a two-dimensional table, that is row and column. Combination of row and column is a table, so that is a relation. In relation, that is tables, data is stored in the form of tuples, rows, and columns. So tuples are rows, your records. You can say a row is the horizontal portion of the table. One row denotes one record of the table, right? Each row in a table is defined by a primary key that does not permit duplicate row, right? Primary key does not allow any duplicate value. Column of a table are called as field names or attributes. Columns of the tables are the field name or attributes. Column is the vertical portion of the table. The number of attributes or columns in a table is known as degree of the relation. That means how many columns are there. Suppose seven columns are there, seven attributes are there in your table, so it will, the degree of that table will be 7, right? And number of rows or tuples in the table is known as the cardinality of the relation. So number of records, number of rows will be the cardinality, right, of the table. Then relational database management system concepts now we are talking about. So one of the RDBMS operators or commands we are talking about. The structured query language, SQL, is the query language which you generally use to query a database to find out data from the database or to extract data from the database. You use a structured query language. Is a popular language for RDBMS that enables you to create and manipulate a relational database. So if you want to create a table, you want to find out something from the database, so you will use SQL only. SQL provides many operators for manipulating tables. SQL has many processing capabilities such as so the processing capabilities of the different languages in SQL are data definition language, data manipulation language, data query language is there, and data what you say, transaction query language is also there for the transactions. So in your DDL, that is data definition language, there are certain commands like create table, create command is there, alter is there, drop is there. So some those kinds of. And in manipulation, data manipulation language, you have different commands like select, sorry, insert, update, delete. So these are your main manipulation language. You can insert certain data in record inside the database. You can update that record, or you can delete that record, something like that. So and you also have query. You also have uh, data query language, that is select. Select is for querying, matlab finding out data or taking out data from the database. So select is also there, right? There are other for transactions also. You have commit, rollback, and all that things are also there. But we are talking about data definition and data manipulation language generally. So the SQL DDL provides commands for creating and deleting tables, creating indexes, and modifying relation schemas, whereas DML provides commands for data retrieval, data deletion, and modification of data stored in the database. What I told you. Using DML, that is data manipulation language, you can also insert new data into the database with insert. For example, DQL select command is used to retrieve data from one or more tables. So select is a command to retrieve or take out data from the database. The syntax is select column name. So you can give multiple column names, or if you give asterisk, that means all the columns you want to return from the table name, where you can also give a condition. Then RDBMS integrity. What is integrity? For maintaining the quality of the database in the information in the database, relational DBMS provides integrity rules. Data integrity means that the data is accurate and consistent in the database. There are two rules of integrity in CORDS models, such as entity integrity and referential integrity. So integrity means that we want to have accurate data and consistent data, right? So for that, you have two rules according to CORD rule. There are two rules. One is entity integrity and the other is referential integrity. What is integrity rule one? That is entity integrity. It defines that each table have exactly one primary key. A primary key is a set of one or more attributes that can uniquely identify each row in a relation. So in a table or in a relation, you should have a primary key which will uniquely identify each record, right? So that is the first integrity rule or entity integrity. The second integrity rule is your referential integrity. Referential integrity is foreign key. So it needs that a foreign key must have a matching primary key. Referential integrity constraint ensure that relationship between records and related tables are valid. So if you want to have a relationship between two tables, one is a student table, the other is a teacher table. So if you want, or you can say, yeah, you have a course table and a student table. Suppose student and course table are there, and you want a relationship between both the tables. So there should be in suppose student ID is primary key of student table, course ID is primary key of course table, right? So the course ID is also mentioned in the student table, but that is not the primary key. That is the foreign key in student table. The course ID in student table and course ID of course table will be creating a relationship between the two tables. For that, you are in one table, the primary key of another table should be the foreign key in another table. That will create a relationship between both of them. That is referential integrity. Can you understand that? Any doubt? What is
No.
integrity and referential integrity? So foreign key
Yes.
is a primary key of one table that is embedded in another table. The primary key as well as foreign keys are shown here. So suppose you have course, this is the course table and this is the student table. Two tables are there. So course code and course name are, this is your course table. Student table have roll number, name, age, and course code. The course code is the primary key of course table. And in student table, what will be the course code? It will be the foreign key.
Foreign keys.
And, right? It will be connected with the student table with this course code only. Right? So the above example shows primary key and foreign keys. In this example, there are two tables, student and course. Course code is the primary key of the course table and roll number is the primary key of student table. Course code is a foreign key in the student table. It would not be acceptable to change Mohan course code to MCS 221 because MCS 221 is not defined in the course table. Right? So that is there. So the foreign key is used to create a relationship between two tables. Right? Then you also have normal forms. What are normal forms? Database design is difficult task. So normalization theory is a valuable support in the database design process. Normalization is a data analysis process. While designing the databases, there are unnecessary repetitions of data. The normalization is used to reduce the repetition of data. So we want to make our database consistent. We do not want duplicacy. We want no repetition. Repetition means duplication. We do not want duplicate data. So for that purpose, unnecessary repetition we want to remove. For that purpose, we want to normalize, right? So normalization process is related to transforming conceptual schema, that is logical data structure, into a computer representable form. It is used to avoid logical inconsistency from table update operations. There are various levels of normal form, such as first normal form to fifth normal form and BCNF, Boy Scout normal form. So a table is in first normal form. So we have to keep on making the table. We can make it up to fifth normal form. So first you have to make your table in first normal form. The first normal form, if and only if all underlying domains of the table contains atomic values. Atomic values means single values, right? Duplicate. There should not be any. What you say? Uh, Duplicate rows, or you can say not duplicate rows, we will say single rows are there, right? Single rows we have to make, that is atomic values we have to make in a table. So first your table should be in the first normal form. All underlying domains of the table contain atomic values, single values. A table is in second, then you have, after making it in the first normal form, now you will go to the second normal form. So first your table should be in the first normal form. After first normal form, now table can be in the second normal form when it satisfies the first normal form, and every non-key attribute fully depends on the primary key. Now you have to select a primary key, and all the other attributes have to be fully dependent on the primary key. Uniquely identify each record. So you will create a primary key, that will be your second normal form. After creating second normal form, now you can go to the third normal form. A table is in the third normal form when it satisfies the second normal form, and every non-key attribute is non-transitively dependent on the primary key, right? So then your all the non-key means they are not primary keys. So non-key attributes have is non-transitively dependent on the primary key. So that will be in the third normal form, and so on so forth. BCNF and fourth and fifth normal forms are also there. So we are not talking about, just giving you a simple information that one by one you keep on transforming your table into the normalization. Then there is a thing which is known as a view. Now, what is a view? View is a virtual table whose contents are derived from one or more tables depending upon the condition. So sometimes what happen, you do not want your table or your data in the table to be updated or inserted or whatever. You do not want that. You want the table to be as it is, but you want to use that table and find some data from those tables, but you do not want to directly use those tables. For that purpose, you will make a virtual table, and that virtual table will have two or more table content, or one table's content, or one or more table content. And upon taking a virtual table, now you can from that virtual table you can manipulate certain things and retrieve the data from those tables. So a view does not physically store data in the database. It is used just like any other table. A view is like is a query like the select from clause that works on the physical table. The purpose of using view is for data security. It permits a user to use the data through the view only, and hidden data is not available to the user. So DML operations such as insert, delete, and update can be applied on the views. Can you understand that? Why views are used?
Yes, ma'am.
So this is what they have just given you an information. What is a database and how do you what is a schema? What is primary key? Integrity rules and all that they have talked about. Now our main purpose is not to know what is database and all that. We want to convert our classes into tables, in database tables. That is the main objective. So object classes to database tables we want to map. So in the previous section, you have gone through the general DBMS and relational database concept that are most useful during the database design process. This section provides you how to transform an object model into a relational database. So this section focuses on extended three schemas architecture of the object model, use of object IDs, and mapping objects to tables. So we'll talk about that. So you have three sections, three schemas, that is external schema, conceptual schema, and internal schema. So external is the high level a model where the closest to the user sees this one, external schema. Conceptual is how the database looks in front of the users, how it is designed, right, in tables and all that. Internal schema is defines the physical storage structure of the database. The following figure 14 illustrates how object modeling connects to the three schema architecture. So this is how it is. So you have external table models, right? Conceptual table model and internal schema. SQL code is the internal one. So this one is you are mapping object model to external table model or conceptual model to conceptual table model. So this you are modeling, and this is the code. External internal schema is the code, SQL code, actual code, right? So that is what they are talking about. So internal, it defines a physical store. So in the first step toward this design, you should develop object models for the external and conceptual schema, and after this you should transform each object model into table model. Views and interface programs which are connected with external tables convert to conceptual table transform these into internal schema. So the object model defines the static structure of the objects in a system and their relationship. So it emphasizes on logical data structures. Each object model contains classes, association, generalization, and so on. The goal of constructing an object model is to grasp these ideas from a real world which are significant to an application. You must use any mapping procedure which transforms the object model to the table model. There are many mapping alternatives, and they comprise mapping rules. For example, if you want to map association to the table, then there are two alternatives for mapping association. Similarly, when you transform the generalization to relational table, you can use different strategies. You will study mapping associations in section 14.5. You'll be doing that. So during transformation, you can also insert some point or keys into the table which are missing in the object model, such as primary key and candidate keys for each table and foreign key wherever required. Also put some constraints on the attribute, whether each attribute can be null or not null. So those attributes are defined as candidate keys and generally should not be null. You must assign a domain to each attribute and list groups of attributes that are frequently accessed. So that is there. The internal schema of the three schema architecture contains SQL commands which are used to create the table. The attributes assign constraints and keys. The latest database software version comes with a wizard facility that automatically creates tables and indexes. While designing a relational table, you should put restrictions on length and legal characters for names and all that. So that is there. That is what they are talking about. So they are saying what is the use of object IDs? An object identifier is a unique name for any type of object or entity. So object ID is that it is mechanism to identify an entity which should when you derive a table from the class, each table has an ID for the primary key. So object identifier means that you will have a unique name for any type of object or entity. Like student will have student ID, right? That will be the primary key, right? So to when you are making a table from the class, so you will have each table will have an ID which is the primary key. When you derive tables from association, then one or more ID object IDs collectively form the primary key. So if you are creating a relation into a table, a relation can also be created as a table. So if you're creating a relation or association as a table, so in that you can have multiple IDs. One or more IDs will be there collectively, which will form as the primary key. So an ID is equal to the database concept. In a database, an object ID is a set of integers. You uniquely identify each row or record in a table. So that is your primary key. There are some advantages and disadvantages of using IDs. The benefit is that it does not make any changes to the data. The stability of ID is mainly important for associations as they refer to objects. Any changes in the name of IDs will update many associations. So IDs give an unvarying mechanism for referencing objects. The disadvantage is that RDBMS does not support the IDs. Actually, there are no concept for generating the IDs in RDBMS because it processes the data located and manipulated based on attribute values. So you can define IDs as attributes for your tables, except a mechanism for handling them in the relational database you have adopted. So you cannot use IDs in an application where you directly access the database. So you have to make IDs as attributes. That is your primary key. A column will be there, which will be the primary key. Now, mapping object classes to tables. So now we want to map object classes to tables. So when you map objects to the relational model, you shall start with the attribute of the class. These attributes will translate to one or more columns in a table of relational database because some of the attributes are used for temporary calculations. For example, an employee class may have a gross pay attribute that is used for some calculation. It means that all attributes will not be transformed to tables or persistent storage. While mapping objects to tables, objects in a class may be segregated horizontally or vertically or for ease of access. For example, if you have a class with many attributes but few are often used, then you can segregate frequently access objects in a table and the remaining objects in another table using horizontal partitioning. Right. So in a similar manner, if a class has attributes with different access forms and partition of the objects vertically, both types of partitioning are useful. So you can partition a table vertically or horizontally according to that. For example, an employee class may have a gross pay attribute that is used for some calculation. It means that all attributes will not be transformed to tables or in persistent storage. So that is there. So you can do horizontal partitioning. So for if you have a class with many attributes but few are often used, then you can segregate frequently access objects in a table and remaining objects in another table. That is known as horizontal partitioning. In a similar manner, if a class has attribute with different access forms, then partition the objects vertically. So both the partitioning are useful and they improve the efficiency. Like here, student ID and name are put in one table and student ID and address is put in a separate table. So with this is a primary key of this, and here you can access with through this primary key. Relationship will be through the primary. This is vertical partitioning of a table. Right, horizontal partitioning is like that. Student ID, name, address, three of the columns are there, but the records are partitioned. So first is this, and the third one is in a separate table. Records are partitioned. This is known as horizontal partitioning. You can do that. You can partition the table according to vertical or horizontal partitioning. So you can see in the figure where an object class is converted into a table, class student has attributes such as name and address, right? Like the here, right? You can list these attributes in the table model and insert the implicit object ID into it. So student name and address was the class, student was the class, and name and object address was the attribute. So here we have implicitly added the ID, student ID here, right, in the table, and name and address are the attributes here. So that is made into a table. So you during making a table model, you can mention more details. You can specify student ID, which cannot be null because it is a candidate key. The name attribute cannot be null. A name must be entered for every student. So this is also not null. Name also, you cannot define name of the student as candidate key because two students may have the same name, but the address attribute may be null. Address can be left null. You can also assign a primary key to each table. The structured query language is used to create the student table. So if you see here, so this is the model you have created. Attribute name, the null or not null, you will define in null. Domain also you are defining. So student ID is the attribute, not null. This is the ID. Name is the another attribute, again not null, and name is the domain name. Address is null, yes, and address is the domain. So this is, you have mapped the this class into a table model. Right now, for creating student table, the SQL code is create table student, circular bracket, student ID. Here you will not ID, you will say data type. You can say int or whatever data type you want to mention. You can say that. Not null, right? Name. Even if you don't write not null, when you are saying it at the bottom primary key student ID, it will automatically be not null. But you can say not null also. Name, varchar. Varchar is the data type. So you can see this is MySQL code they have written. So in MySQL, you can see all the data types available. So student ID, I think int is available. I think in number or int, one of the two thing is available. And name is varchar, is for variable character data. So 30 is the size of that name, size is there, not null again. Address again varchar 30. For setting the primary key, you will write primary key, and in circular bracket you will give which row, which column will be the primary key. Student ID will be the primary key, and circular bracket close semicolon. This is how you create a table in SQL code. This table, which you have transformed. Can you understand how class
Yes,
is transformed into a table?
your voice is disturbing little bit due to some connection or
I
whatever it is.
connection is not proper now. Is it audible now? Is it audible? My voice?
It is, yes, now it is audible.
Okay. Now, you have seen that how you are mapping a class into a table. Now, mapping association to table. Association is your relationship. So, association is the relationship between two separate classes to their objects. Associations are generally denoted as continuous lines between the participant classes in the relationship. An association may be one to many to many, or a ternary association. So association mapping to tables depends on the association type and multiplicity of the association. This section will be mapping different types of association into database tables. So mapping binary associations to tables. This section describes the mapping of one-to-one association and one-to-many association to the table. In one-to-one association, one occurrence of a class is related to exactly one occurrence of the associated class. For example, the following class diagram shows one-to-one association between country and city. So in the figure, relationship has a type has capital, shows how each country holds exactly one city as the capital city, right? So one country will have one capital city, right? That is what they are portraying here. So while mapping such a relationship to the table, the primary key of one table is included in another table, which means that you can handle one-to-one association by using foreign key. So like in the above example, country code is a primary key of the country table. The primary key of the country table is country code. City code is the primary key of city table, right? The foreign key, that is primary key of the country table, is inserted into the city table like this. So when you are mapping mapping it into table, so you will say create table country, circular bracket country code int. This is the exact MySQL thing. So int there, data type int not null. Country name, the second attribute is country name, right? Varchar 30 not null. Primary key country
The
code
screen is not
and circular
moving.
bracket. What?
Screen is not moving. That is
What
the
is not?
text material is fixed. Text material is fixed at one point.
Now you are not able to see my screen. What I'm teaching right now is not moving.
You're when you're teaching this
No,
country and city, that was fine, but now you are teaching about the SQL code, but code is not there in the screen. No, madam.
I'll just stop share and share again. Wait,
Okay, okay.
wait. I'll just stop share and share again. Is it visible now?
Yes, sir.
Huh. So what code have we created? Create table country bracket country code. Int is the this is the actual code of SQL. Int not null. Country name varchar 30 not null. Primary key is country code and circular bracket close and semicolon. This is for which this code is for which table? Country, right? We are
Yes.
not concerned. We are not concerned with the methods. We are only concerned with the name and the attribute of the table, right?
Yes.
Then city table we will create table city. City code is the primary key and city
Primary
name of
key of
that,
the city.
right? City code int not null, city name varchar 30 not null, country code int not null also we have added. Why we have added country code? Because there is a one-to-one relationship, and for
Relationship.
foreign key we have to add a country code and city code, right? So the
Yes, sir.
primary key of this table has to be added in the table also. Now primary key is city code of city table, right? Comma, foreign key country
City
code.
control.
Foreign key
Yes.
is country code and
Right.
reference is country table. Reference is
Yes.
country.
Hmm.
Circular bracket close semicolon. So this is a foreign key you have created. Country code is a foreign key, which is a reference from the country table, primary key of the country table. Now the relationship is set, right? Association has been set. So now whenever you are saying the country code, this, what is the uh, city code, or you can say what is the capital city of that, so you can find out that because there is a relationship in both of them, right?
Right.
So that is how you map a class or association into a table, right? Same way, now another one is one to many association.
Okay.
So one to many association, one occurrence of a class is related to many occurrence of the associated class, one or many. So in a university, there are many employees working,
Yes.
right?
Mm.
So to portray that, we have a relationship table also.
Mm.
And that relationship table is saying a university employee is the name of the EMP, is the name of the table, and job title and salary are inside this table, in the association table. Can you understand that?
Yes, ma'am.
Right. So when you are mapping as one to many association to table, you can have two options. One may you may use a foreign key in the table for many class, or
Mm.
create a distinct table for each association. You can create a distinct table
Mm.
for each association. So using the first option, you can create a table model from the object model like this.
Yes, yes.
University table and employee table you have created.
Mm-hmm.
University ID is being kept in the this employee table as the
Yes.
prime foreign key.
So domain is the foreign key in employee table, no?
Yes, this is your primary key in the university table, and here in
Yes.
the employee table it is the foreign key.
Yes.
Right. One thing,
Yes.
one kind of a thing you can do like this.
Yes.
The first option. The second
Yes.
option is you can create a distinct table.
Mm-hmm.
So you can use figure 14.8. There are two tables, university and employee table. The university ID is the primary key of the university table, and employee ID is the primary key of the employee table. The foreign key, that is the primary key of the university table, is inserted into the employee table. You can create relational table using the table model defined in 14.8 SQL code you can generate. So they have not created it. Again, SQL code can be created like this for the university and for the employee,
Employee
like
code.
this way, right? That is
Yes.
one kind of a thing. The another kind is you create a university table and an employee table with the attributes given, and you create another table which is known as university employee, where university ID and employee ID both will be there, and apart from that, job title and salaries are there, which is this one. Can you understand?
Yes.
Right.
Right.
University ID, the primary key of university ID will be inside this. The employee ID, primary key of employee, is also there.
Mm.
Both the tables employer. So in this table, in university employee,
Yes.
university ID and employee ID both are primary keys also, and both are foreign keys also.
Okay. Yes. Because they
Okay.
are taken from the above two tables.
Yes, and they are primary key of this table also.
Right.
So you can see the table model of this figure. The table model consists of three tables: university employee and university employee. Here, all the classes in the association are mapped into a distinct table. The university ID is a primary key of university table. Employee ID is a primary key of employee table. Attribute university ID and employee ID join together to form the only candidate key for the university ID, university employee table. Now you can create relational tables like this. So if you want to create a table, it will be create table university, university ID, university name, university address. Primary key is university ID, right? Create table employee, employee ID, employee name, employee address you have taken. Here they have primary key is employee ID. So these are the two tables you have created. Now the create table university MP, right? University ID, employee ID, both are there. Then job title and salary you have put. Primary key is university ID comma employee ID, both are primary keys of this table. But foreign key, university ID reference university, foreign key employee ID reference employee will also be there. Can you understand?
Yes, ma'am. It's quite simple.
This is how one to many association is done
Yes.
using distinct table.
Yes. It comes in examination, madam.
Yes, not in
Okay.
may or may not. It's not
Okay.
general, but in
Okay.
your practical this, can you see that?
Yes.
You
Do the
have to
mapping of the
map
classes.
you
Yes.
have to match this to classes. So customer name, phone, address, pin, email,
Yes. You can.
right? So in this
Right.
they have not mentioned the customer IDs.
Yes.
So you have to mention that yourself,
Okay. Okay.
right? As a primary key.
Okay.
Now order date, product sold by, product order cost in product ID will be one of the primary keys of this
Yes.
table. You
Yes.
have to mention that. Product
Mm-hmm.
name, manufacturer, product ID is in this product ID is there. So this will be your primary key, unit price and unit in stock, right?
Right.
So these are the three tables you will convert it into tables. Now there is a relationship table. In these two tables, how will you create a relationship? You can create a order ID either in customer ID, customer table,
Uh, uh, we can
order
create
ID.
a table of customer order and product.
Nick, first I'm talking about customer and order table you have created, right?
Right.
Right. So in the to create a relationship between the two, there is no relationship table created. So for that, we will
Mm.
create a foreign key concept, right?
Yes.
So
Customer ID.
in the customer table, order
Yes.
ID we can keep as foreign key in the customer table,
Okay. All right. We can do this.
right? So that will
Right.
create a relationship between that.
Hmm.
One option is this, right?
This will be done. Yes.
Right. In these two, order and product. Now to create a
Yes.
relationship between these two, we will create a third table,
Mm.
which is the order line table.
Mm.
Okay. Quantity and unit sale price are the attribute, but we will
Mm.
add order ID and product ID as the primary key and foreign key both in this table.
Yes. Right. Mm-hmm. Yes, it's fine.
This is how you will map it into a
Mm.
table
Table.
format. That's what I'm talking about.
Yes.
Now, mapping many to many associations, we have not seen that. So, in many to many association, m occurrence of a class is in a relationship with n occurrence of the associated class, right? Like here, course and student. Many courses, many student. Many student enroll for many courses, right? So, many to
Yes.
many relationship is there. So, registered. So, they have created a distinct table that is registered for where qualification is there, right? This is the relationship table. So while mapping such relationship to tables, you require an associative table that reference the primary keys of the associated records. So primary key will be referred in the registered for will be course code and student ID, right? Both will be the primary key and the foreign key.
Mm.
Right. The name of this associative table is usually either the combination of the names of the table that it associates or the name of the association that it implements. So the name of this table will be either the name of the combined two table names, course student, or the relationship name. Understood? So here we have put registered for as the relationship name is the name of the table. In this, we have combined the two university employees, university AMP. You can do like this also. You can name the relationship table or you can name it
Mm.
the relationship name. Accordingly, you can do,
Mm.
right? So if you need to store any extra information of this relationship, you can add columns to the associative table. Like here, they have added qualification. Let's see an example of such a relationship in class diagram. So this is your example they are talking about. This example contains two classes, course and student, and one associated class. The relationship type registered for shows how each course has M student registered for, whereas depicted other. Each student registered for N courses, different courses. Now you can create a table model by taking the help of the example. So here they have created that. So you have the course table. This is your course table with course name, course code and course name, and course code is the primary key, right? This is your student table where student ID and student name are the attributes and primary key is the student ID, right? And create table registered for. This is the association table. Course code and student ID are there, and qualification is also there, the attribute. Primary key will be course code comma student ID. Both are primary keys of this table. And foreign key course code reference course, foreign key student ID reference student. Understood? This is how many to many association is represented.
Right.
Right. So this is how you are mapping it into table. So you have seen the above example of many to many association. While mapping to table, primary key of both the tables, that is course and student, are included in another table that is registered for as foreign keys along with the attributes of the relationship. So these keys combine to form the new table's collective primary key also. Right? Any problems in this?
No,
Right?
madam.
It's simple
No.
to convert. There is no issue in that in converting. Mapping ternary associations to tables. So when the three
Mm,
classes are involved in a relationship, it is called ternary association. So three tables
mm,
are involved, right? One,
mm.
two, and three.
Two.
Course,
Mm,
student, and assignment. Three
yes.
tables are in a ternary relationship. So when you are
Mm,
mapping these associations to tables, all classes shall be mapped onto a distinct table, and the relationship shall be taken by creating another table with primary key, which must be combined primary keys of all the three classes. Right. So we have created a ternary table out of this because there are three tables: course, student, and assignment. The ternary table will
we
have
have
all
all in it.
primary keys of this table, and which are also
Yes.
foreign key and primary key in this table,
Yes. Yes.
right? So
Right.
it would also include the relationship attributes such as start date and end date. So you will also have its own attribute also, start date
Mm,
and end date. Let's see the following ternary diagram. So they are talking about this diagram. So you have course table with course code and course name, student table with student ID and student
right.
name,
Right. This one is any.
and assignment is assignment ID, assignment name.
It's any.
And in the third table, that is your ternary
Mm,
table, course code,
yes.
student ID, assignment ID, which are the
Start
primary
date.
keys of these three tables, and start date and end date will be there. This will be a ternary association. And the converting is this one. This is your course
Same.
table, the primary key course
Mm,
code. This is your
yes.
student table with the student ID as the primary key. This is your assignment table with assignment ID as the primary key. And the third table, ternary table, will have course code, student ID, assignment ID as the primary key, plus start date and end date, and foreign key reference the course code referencing course, foreign key student ID reference student, foreign key assignment ID reference assignment, like this, right?
Yes, ma'am.
So this is how you are mapping what a
So
ternary
what is
association
ternary
also.
association?
This is a ternary association you are mapping,
Right. Yes.
right? Now mapping generalizations to table. You know what is generalization? Inheritance.
For everybody.
Inheritance. It is kind of
Yes.
an inheritance.
Yes.
Right. So, as you know, generalization is a superclass, subclass type of a relationship. You have a parent and child relationship, right? Inheritance. So that the employee superclass is a generalization of the entity subsets such as salaried or hourly employees. So, for example, you have an employee class, and there are two types of employees. One is an hourly employee, the other is a salaried employee. Can you understand that? Right. So if you are modeling an organization database and want to store information about their employees, either salaried employees or hourly employees, in this case, you can create an employee set that would be called as an superclass, and salaried or hourly employee subset, which is also known as your subclass, like this: employee, salaried employee, hourly employee. This is generalization you have done, employee type. Right. So, salaried employee will have monthly rate as the salary, and hourly employee will have hourly rate as the salary.
Mm,
Right. And name and address are the common attributes
attributes.
in both.
Mm,
Right. Just an example, matlab we are showing. So these
yes.
are different tactics or strategies used for mapping generalization relationship to tables. So map the
Hmm.
superclass and each subclass to a table. If strategy one is applied, strategy one is map the superclass and each subclass to a table. So you have employee is the main class, superclass, you can say. Employee ID, name, address, and phone number. Yes. You have another class which is salaried employee. You have another subclass which is hourly employee. Salaried employee has employee ID and monthly rate. Hourly employees are employee ID and monthly rate. This is one thing you can do. Can you understand? This is vertical, kind of a vertical partitioning you have done. Yes or
Yes.
no?
Yes. Yes.
Right. You can create a table for the superclass entity as employee, which includes all the attributes of this employee entity in the table and underline the primary key attribute. So, underlined one is the primary key. You can also create a separate table for each subclass entity, same as a superclass entity.
Hmm.
Include the attributes of the respective subclass in the subclasses in the subclass table. Take the primary key from the superclass table and insert it into the subclass table as a primary key and underline it like this. This is strategy one.
Yes.
Right. Now, what is strategy two is map each subclass to a table. Like using this method, you can only map subclasses to tables. You do not
Hmm.
map the superclass to a table.
Hmm.
That the attributes in the superclass are duplicated in all the subclasses.
That means we are making two separate
Yeah.
tables.
So we are not making the superclass table. We are not making the
Yes.
superclass table. We are making the subclass only. We are only mapping subclasses. So that
Yes.
means salaried employee and hourly employee we are making. And in that, employee ID, name, address, phone number, monthly rate, employee ID, name, address, phone number, hourly rate.
Right.
This is another way. The second
Yes.
strategy. Only
Hmm.
mapping the subclasses.
Yes.
Right. So here you can create a isolated table equivalent to each subclass entity with the involvement of attributes of the corresponding subclasses in the corresponding subtables. You can also add the superclass entity's primary key and other attributes in all the subclass tables and underline the primary key fetched from the superclass entity to the subclass table. This strategy is most chosen when inheritance is disjoint and complete. Example, every employee is either salaried or hourly or none. Can you understand what does that means when inheritance is disjoint and complete?
Yes.
Every employee is either salaried or hourly or none, then this strategy is used.
Uh, Nothing is common in between them, then we have to
Yes.
use this table.
Yes. This is the second strategy.
Hmm.
Right. Now the third strategy is map the superclass to a single table. You do not have any subclasses. Can you understand that?
Hmm.
So in this case, only the superclass is mapped to a table and does not map the subclasses to tables. The attributes in the subclass are brought to the superclass. So here, if you see employee, employee ID,
Hmm.
name, address, phone number, monthly rate, hourly rate.
Yes.
Now, whoever employees have monthly rate will be in monthly rate. Whoever and those employee who do not have monthly rate will not have anything mentioned in the monthly rate,
Hmm.
and they have
Hmm.
hourly rate, so it will be mentioned in the hourly rate column.
Yes.
So this kind of a strategy. So using this
So
strategy,
this type of strategy is basically used when we have some plans for some software we see in on our web page that the software is having uh, monthly subscription, yearly subscription, and so
yeah,
monthly
some kind
subscription
of
has
a thing.
some
We can have
features
that.
some features that are not available for the yearly subscription, and like yearly subscription everything is available, but for monthly subscription some features are not available for that, so
Yes,
that type of thing is it is.
yes. So using this strategy, you can create a single table containing the superclass entity and its attributes along with the subclass and their attributes. This strategy will introduce null values because I told you na, in those who have monthly rate will have values, but those who do not have monthly rate will have null values, right? In monthly rate, they will
Yes.
have values in the hourly rate.
Definitely that is it.
Right. So when you insert a salaried employee record in the table, the hourly rate column will be null.
Yes.
Similarly, when you insert an hourly employee record in the table, the monthly rate value will be null,
Well,
right? So this strategy may be useful when there are only two or three subclasses consisting few attributes.
yes.
Then this is probably suitable.
Yes. Just like we have an Amazon Prime, we are subscribing, so it shows that if you have a weekly plan, monthly plan, or yearly plan,
Right,
then you have three type of things that in monthly plan you cannot access to one or more devices, but when you have an yearly plan, you can have access to two or more devices. Like that, it
right,
is.
right. So some these three strategies are there, right? Now, whatever kind of database you are creating, that particular strategy you can use. You can use strategy one also, you can use strategy two also. In strategy two, you do not have anything common, disjoint it is. And in strategy three, you can have, if you have less, a few attributes are there, so you can map it into a one table only. Only thing is that certain tables will have null values accordingly. But that's the thing. So this is according to your own structure, what strategy you make. Can you understand all these things? How you are
Yes, ma'am.
mapping tables to, sorry, classes to tables.
Yes, yes, it is clear.
Right. Now they are talking about interfacing to databases, right? A DBMS is a software program which is used for creating, retrieving, and controlling access to permanent data. As the focus of this unit is on object mapping to databases, this section is to discuss the relationship between object orientation and relational databases and some interfacing point with the database. Object oriented technologies unanimously recognize methodology for developing business applications since it provides more suitable methods and services for modeling objects from the real world. Object orientation and relational databases are not compatible, if you say. There are object oriented databases also, you know that? OOAD databases are also there, right?
Mhm.
So both, but when you are talking about object orientation concepts and relational databases, they are not compatible. Both represent two different views. In an object oriented system, concepts are surrounded by discrete objects which combine both data structure and behavior in a single entity. In a RDBMS, all about the data or data centric. Everything is about data and data centric it is. So the object oriented model is suited with applications with state specific behavior, and data is a secondary point. The RDBMS model is well matched to reporting applications in which the relationships are dynamic and still used to preserve the persistence of enterprise data. The discussion point here is that a lot of data is stored in relational databases. If object oriented applications are used to store data in RDBMS, then it is more able to read and write data in the relational database. Besides, object oriented applications can share data with non object oriented applications by using RDBMS as the sharing mechanism. Connecting these two standards is not an easy task and requires organized mapping from one to another. This mapping from object model to the relational database needs some rules and strategies, which we have already discussed. So, this is a strategy you will use to map classes into tables. Can you understand that? The association, the ternary association, and this
Yes,
thing. This has to be taken care of.
yes.
So while creating classes, you may not create this relationship class. Some of you may not create this relationship classes. This, right? You are just creating course, student, whatever are there. Sometimes you are not creating this relationship class. But when you have to map this class diagram into your
Mhm.
tables, then you have
Mhm.
to have,
Yes,
like, you have many to many relationship. You should have a third table or an association table mapped accordingly. So that has to be done. Otherwise, you will not be able to map it into a relational database. That is what they are telling you, right? So,
right.
here, if object-oriented applications are used to store data in RDBMS, then it is more able to read and write data in the relational database, and they can also share the mechanism which we have done. Connecting these two standards is not an easy task and requires organized mapping from one to another. This mapping from object model to the relational database needs to rules and strategies which we have seen. Once you have transformed object-oriented data model to relational database, you shall write the interfacing code responsible for application's functionality, so that you know that your application, suppose it is Java or C++ or whatever object-oriented programming language you are using, and the intermediate code you have to write to connect it to a database, that you have to do, right? That is also there. So this code must contain commands capable of reading and writing database from the writing data from the database and interpreting it whenever requisite in terms of model used by the program. To achieve this, you need interfacing software. Like in Java, it is JDBC API, right? Java Database Connectivity. ODBC is also there, object, right? Which supports your programming environment and allows programmers to shorten the details of individual databases and allows an application to work with a variety of database or data sources. So JDBC API is a Java API which can be used to access any kind of tabular data, especially data stored in a relational database. It allows Java programmers to write programs which interface with relational databases. It has three simple steps to connect a database, such as connecting to a data source like a database, sending queries and update statements to the database, and retrieving and processing the results received from the database in the is answer to the query. Right? Can you understand
Yes,
what
ma'am.
they are talking about?
Yes.
So to connect your application, your programming language to a database, you have an API inserted for the connectivity of database to the programming language, right? Like for
Yes, ma'am.
Java, it is JDBC API, right?
Yes.
So for different programming languages, you have ODBC and other APIs also, right? So for that, you should know that how to connect with the Java API. For Python also, Python is also works as an object-oriented programming language. So you can connect with Java with Python also. You have an API. So that is what they are talking about. So they're just giving you simple information about that. So this is all about your syllabus. This was your full syllabus, right? So they have asked you explain mapping of one to many association into database table. Right. So one to many association was which we had done was I think university and employee. I think,
Yes.
right. This is one to many
Yes.
association. Right. So you can explain that one to many association. So there is a third table university employee we have done. Right. So you can have any example. Ternary association is this one. Student course assignment. Ternary table is there. This is for the ternary association. So they have asked you in the check progress, explain how the ternary association are mapped to database tables. Explain how generalization relationship are mapped to the table. So generalization, you have three kind of strategies: employee, salaried employee, hourly employed. So you have three strategies. Strategy one is this one, where you can have the superclass and subclasses. Second is if two subclasses are there, no superclasses there. Third one is only superclasses there, right? This is how you can map the three classes.
Yes. Mm.
So this is what they have given you an example. So they have
Mm.
given you there. See, the answers to the questions are given here.
Yes.
But if you have to explain, so you can give the diagrams also. You can draw the diagrams in your theory with your
Yes, we
pen,
can give
right? So
examples
and
and diagrams.
examples you can show them accordingly, whatever is asked. So this is what in this part of the question, which is customer order association classes there. So you have these classes have to be converted into database table. Now customer order product, these are the three classes. So
Mm.
here you can have customer ID as the primary key, here order ID as the primary key. So you have to insert yourself,
Mm.
right? And in customer class, you can have order ID as the foreign key,
Yes.
right? And these are connected. And in this, you have a ternary table like this, order line, and
Yes.
order ID and product ID will be the primary and foreign key in order line.
Yes.
So you should know the code how to in SQL how to create a table. You have to write create a table code for this, create a table code for this, create a table code for this, create a table code for this. Right?
Yes, ma'am.
Any doubt?
No, no, no. Clear, it's clear. Everything is
In
clear.
the examination, I don't know mapping table they have asked,
Hmm.
but I don't know in what form. If we go to the question paper, I don't know the website. In the recent papers, that is June 2025, whether they have given the this kind of a question, I have no idea. Right now, so your focus should be on the theory papers
Yes, four theory papers.
because practical for MCA OL it will be Viva based practical, so there is not an issue. You should know if you know the theory, so you will be able to answer everything. There is no problem.
Mm-hmm.
What is OAD? Explain though that this is not a UML inheritance, one-to-one association,
Mm.
object modeling, use case diagram.
One-to-one association is asked. No, that is theory part. One-to-one associations are
How
implemented
about what is
implementation.
one-to-one association they have asked now?
Yes, yes,
They
yes.
are not asking converting into table. I'm searching
What
if
they
there
are, but they are, they are asking that explain how they are implemented. No.
implementation is in the previous section before mapping of tables we have done na, how
Mm-hmm,
one-to-one
yes.
association is mapped into a
Okay.
code.
But if we, but suppose we show these table and SQL code, will it be considered here?
No, this is they are not asking you to convert in class in or association into a table. They are not asking to convert it into a table. They are asking how it is implemented.
Okay, okay, okay.
Implementation is in the previous
Mm,
section which we had done, the C++
mm.
and Java code,
Right, right, right.
right? They are not asking you to convert it into a table.
Okay.
Use case diagram, state transition diagram, component diagram, DFD, design documentation, data persistence. Here they have
Yes,
asked data
short
persistence,
notes,
right?
short notes.
This
I
is
was what
this
I
is
was.
what this is what mapping object classes to tables.
Yes,
Short
this is
note you have to write.
yes. This is what I was thinking that he must be asking in short notes, and that is the
So data persistence and mapping object classes to table. This these two things from that section they have asked,
yes, yes, definitely.
right? And in the previous, I don't know whether they have asked or not. These are the two latest papers which are there. The earlier ones are in the other one. So this is December 2024. This is OAD. Classes are okay. State chart association. This is different types of association they are asking.
Just UML
FD,
diagram.
class diagram, use case diagram, system design, concurrency, design optimization. Here serialization they have
Realization.
where
Yes,
it is
yes, they
used
have
and why.
asked.
This is there. Explain how the object classes are mapped to database tables.
Definitely, I was talking. Definitely, it is there.
Right?
Yes.
Then cohesion and coupling dynamic models and immutable association.
Immediate association.
So this is short note of this. And in the previous sections, I don't know, in the June 2024, Control F, SOCIS. Object oriented modeling, time critical systems,
Persistent
implement.
object, transient object.
Here, persistent object and transient object different.
Yes.
Derived attribute, design optimization.
Association, one-to-one
So
association with
this
the help of a class
is
diagram.
again they have asked one-to-one association and implementation. So remember
Mm,
that this one you should always for implementation part one-to-one
yes,
association you should always know a diagram
yes,
what example can be student or teacher. I'm just giving an example. Once
yes.
not student and teacher will not be one-to-one. What
One-to-one,
else
maybe.
example?
Uh, one order for
Okay.
one customer.
Customer and credit card. I'm just taking an
Yes,
example. Yeah, customer or account,
yes, that
whatever.
is one-to-one.
So one-to-one association, you have to
Mm,
give a diagram example, a class diagram,
mm,
right? And then you have to also show the implementation, a simple implementation, not a full code. आपको नहीं लिखना है. Only the structure you
yes,
have to show that इसका ये ऑब्जेक्ट
the
इसमें भी एक
snippet of that code.
एक क्लास का ऑब्जेक्ट दूसरे क्लास के
Yeah.
ऑब्जेक्ट में आप एक्सेस करोगे, whatever.
Yes.
Right, so that is you should know. Then collaboration diagram, design optimization, abstraction, DFD, dynamic model, use case
Use case.
diagram, aggregation. Here integrity constraints they have asked.
Yes. Yes.
Integrity constraints are your entity integrity and for
Mm,
the referential integrity.
referential
Data should
intelligence.
be consistent, data should be complete.
Mm,
Right. So there are two rules. One is entity integrity for primary key. The other is referential integrity for foreign key. तो वो
mm,
पूछा है उन्होंने इम्प्लीमेंटेशन ऑफ कंट्रोल ऑब्जेक्ट मॉडल. तो ये चीजें इसमें से पूछी हैं. तो मैं बस ये बोलना चाहती थी फॉर शोइंग यू दिस. आई जस्ट वांटेड टू से दैट just download the previous 5 question papers. One is June 2025, then December 2024, June 2024, December 2023, June 2023. These 5 papers just download. और उन प्रीवियस 5 पेपर्स से आपका पूरा क्या कहते हैं ना syllabus will be covered and you will be able to understand what kind of questions are asked generally.
okay.
That's what my point is. इसीलिए मैं बता रही थी. तो ये जो हमने अभी देखा इस इनमें से आपने देखा कि किस तरह के क्वेश्चंस आपको पूछे गए हैं.
Yes.
राइट, मोस्ट ऑफ द टाइम तो मैपिंग का क्वेश्चन भी आ रहा है थ्योरी में.
हाँ,
ठीक है ना, मैपिंग का क्वेश्चन भी आ रहा है और इम्प्लीमेंटेशन में ज्यादातर वन-टू-वन एसोसिएशन का इम्प्लीमेंटेशन आ रहा है, बाकी तो
हम्म,
नहीं है. बाकी आपको डायग्राम तो कोई भी आ सकता है.
हाँ, इसमें तो
Diagram,
कोई.
they can ask you class diagram. What is a class diagram? Give an example of a class diagram, right? Then they can also ask you, or they can directly give you make a class diagram for online banking system, yeah, whatever online student management system, right? They can directly also ask you. Then use case भी आ रखा है, sequence diagram भी आ सकता है, collaboration भी आ सकता है, activity नहीं आया है कभी, state chart भी आ सकता है, component भी आ सकता है, deployment भी आ सकता है. आने को तो कोई भी डायग्राम आ सकता है, उसका डेफिनेशन आ सकता है, व्हाई इज इट यूज्ड आ सकता है. तो ये मतलब हर डायग्राम का आपको सबसे पहली चीज क्या करनी है व्हेन यू आर प्रिपेयरिंग फॉर योर एग्जामिनेशन. स्टार्ट विद द डायग्राम्स फर्स्ट. तो डायग्राम्स की डेफिनेशन, व्हाट इज द पर्पस ऑफ दैट डायग्राम, व्हाट काइंड ऑफ डायग्राम इट इज, डायनेमिक और स्ट्रक्चरल डायग्राम किस टाइप का डायग्राम है. ठीक है ना, ये सब लिखना है. अगर शॉर्ट नोट में भी आता है तो वो काम में आएगा आपको कि डायग्राम क्या की डेफिनेशन क्या है, वो डायग्राम कहाँ यूज होता है, किस टाइप का डायग्राम है, और एक एग्जांपल उसका कैसे ड्रॉ होता है. ये तो हर डायग्राम का आपको पता होना चाहिए, ये तो लिख के रख लो कहीं पे. कैन यू अंडरस्टैंड व्हाट आई एम सेइंग.
yes.
तो ये तो इम्पोर्टेंट है ही, थ्योरी एग्जाम में ये तो आएगा ही, कोई ना कोई डायग्राम तो आ जाएगा. तो सारे डायग्राम तो पता ही होने चाहिए, उनकी डेफिनेशन क्या है, कैसे क्यों यूज होता है वो, उसके कंपोनेंट्स क्या है पता होने चाहिए, क्लास होता है, जैसे क्लास डायग्राम में क्लास है, लिंक्स है, जनरलाइजेशन, एग्रीगेशन, कंपोजिशन, ये सब चीजें पता होनी चाहिए आपको। दैट इज इम्पोर्टेंट।
दो तीन डायग्राम तो ऐसे हैं जिनमें उनका खाली एक रिप्रेजेंटेशन ही डिफरेंट है, बाकी चीजें वही हो रही हैं उसमें।
हाँ, मतलब ये स्टेट चार्ट और एक्टिविटी डायग्राम थोड़े सिमिलर हैं,
हम्म,
लेकिन स्टेट चार्ट में डिसीजन मेकिंग को दिखाया नहीं जाता डायमंड से, एक्टिविटी में फ्लो चार्ट की तरह डिसीजन मेकिंग को डायमंड के उसमें इफ कंडीशन वाला जो दिखाया जाता है, स्टेट चार्ट
हम्म,
में वैसे नहीं दिखाया जाता,
हम्म,
कंडीशन टाइप में नहीं दिखाया जाता उसको। तो एक्टिविटी में वो होता है, बट थोड़े बहुत दोनों सिमिलर हैं बनाने में। इसमें भी स्टार्ट स्टॉप होता है, इसमें भी स्टार्ट स्टॉप होता है। वो जो फील्ड ब्लैक सर्कल स्टार्ट है, और हॉलो सर्कल के अंदर फील्ड सर्कल स्टॉप है, दोनों में, राइट।
यस मैम।
कोलैबोरेशन डायग्राम और सीक्वेंस डायग्राम सिमिलर है, लेकिन बनाने का तरीका अलग है।
हाँ, उसमें एक एरो दिखा के उसमें जो जो प्रोसेस होते हैं वो
दोनों,
1 2 3 वो
हाँ,
नंबरिंग कर
दोनों
देते हैं उसमें।
दोनों इंटरैक्शन डायग्राम्स हैं, इंटरैक्शन डायग्राम
हाँ,
के अंदर आते हैं दोनों, लेकिन सीक्वेंस डायग्राम में सीक्वेंस वाइज एक एक एंटिटी के बीच में, ऑब्जेक्ट के बीच में क्या कम्युनिकेशन हो रहा है, ऐसे बार
वो
बार में
दिखाना
आपको,
पड़ता है, दिखाना पड़ता है उसको।
बार बार में बार के फॉर्म में दिखाते हैं,
हम्म,
वर्टिकल बार्स के फॉर्म में कम्युनिकेशन हो रहा है।
पेपर
कोलैबोरेशन
में टाइम
डायग्राम,
दिखाया हुआ है।
कोलैबोरेशन डायग्राम में हर एंटिटी के बीच में लाइन दिखाते हैं, और उस लाइन के ऊपर 1 डॉट ये हो रहा है, 2 डॉट ये हो रहा है, 3 डॉट ये हो रहा है, ऐसे ऐसे कम्युनिकेशन हो रही है।
सीक्वेंस डायग्राम पेपर में टाइम ज्यादा यूटिलाइजेशन करेगा ये।
हाँ, इसमें थोड़ा ज्यादा ड्रॉ करना पड़ता है,
हम्म,
ये थोड़ा फिर भी चल जाता है। तो ये दोनों सिमिलर हैं। यूज केस डायग्राम अलग है।
हाँ, वो एकदम
यूज,
अलग ही हो गया।
हाँ, वो तो एक्टर और यूज केसेस और प्रोसेसेस
बीच में
दिखाने पड़ते हैं आपको।
एक्टर दिखा दिया, एक्टर के साथ जो जो प्रोसेस हो गए उन्हीं के
हाँ,
साथ
जो जो
कनेक्ट
प्रोसेस
करके।
चल रहे हैं, जो जो यूज केस चल रहे हैं, वो दिखा दिए। और ये यूज केस से ही आप सीक्वेंस डायग्राम बनाते हो और कोलैबोरेशन डायग्राम बनाते हो। कैन यू अंडरस्टैंड? एक यूज केस, जैसे बुक
हाँ,
टिकट का यूज केस ले लिया, तो
हाँ,
वो बुक टिकट का सीक्वेंस डायग्राम बताओ कि कैसे बनेगा, बुक टिकट कैसे होएगी, या कोलैबोरेशन डायग्राम की बुक टिकट कैसे करोगे।
हम्म,
एक यूज केस को पोर्ट्रे करना, ये सीक्वेंस डायग्राम और या एक्टिविटी डायग्राम या स्टेट चार्ट डायग्राम, एक यूज केस को पकड़ के आप बना सकते हो। इसीलिए
हाँ,
मल्टीपल स्टेट चार्ट डायग्राम बन सकते हैं, मल्टीपल एक्टिविटी डायग्राम बन सकते हैं, मल्टीपल कोलैबोरेशन, मल्टीपल सीक्वेंस डायग्राम बन सकते हैं।
हम्म। इसमें डिपेंड कर रहा है कि हम किस चीज को कंसिडर कर रहे हैं उसमें ना,
हाँ,
इस पे
मतलब
डिपेंड।
एक यूज केस को लेना है ना। अब जैसे लॉगिन एक प्रोसेस हो गया, यूज केस हो गया एक
हाँ,
लॉगिन, तो
हाँ,
उसका अलग सीक्वेंस बन गया, कोलैबोरेशन बना दिया, फलाना बना दिया। फिर
हाँ, ये है।
लॉगिन के बाद आपने अगर ब्राउज का बनाना है, ब्राउज का अलग बन गया। जो भी
हम्म,
प्रोसेस होगा, बुक टिकट है तो बुक टिकट का अलग बन गया। तो अलग अलग प्रोसेसेस जो यूज केस में यूज केसेस होंगे ना, अलग अलग,
जी।
तो एक्टर जिनसे कम्युनिकेट कर रहे हैं वो अलग अलग यूज केसेस को इनके थ्रू आप बना सकते हो।
हम्म,
दैट इज द प्रोसेस। क्लास डायग्राम तो बिल्कुल डिफरेंट है, वो तो आपका क्या है, ऑर्गेनाइजेशनल डायग्राम है, स्ट्रक्चरल डायग्राम है वो, कि ये
हम्म,
क्लासेस होंगी आपके प्रोग्राम, मतलब सिस्टम में, और उनके
हाँ,
ये एट्रीब्यूट्स होंगे,
हम्म,
और ये मेथड्स होंगे।
हाँ,
तो वो डिफरेंट है बिल्कुल। और कंपोनेंट और डिप्लॉयमेंट डायग्राम भी डिफरेंट है। कंपोनेंट डायग्राम आपका और डिप्लॉयमेंट आपका आर्किटेक्चर बताते हैं सिस्टम का,
हाँ, हम्म,
कैसा आर्किटेक्चर होगा,
हम्म,
क्या सॉफ्टवेयर में आर्किटेक्चर होगा, क्या क्या आपके हार्डवेयर में आर्किटेक्चर होगा।
हाँ, ये तो।
तो ये हर चीज का क्या पर्पस है, इसीलिए मैंने बोला सबके डेफिनेशन, सबका पर्पस,
हम्म,
सबका क्या कह लो, इम्पोर्टेंस क्या है, या यूज क्या है उस डायग्राम का, वो पता होना चाहिए, अपार्ट फ्रॉम वो कैसे ड्रॉ होता है। इसीलिए ये
हम्म,
सब चीजें इंपॉर्टेंट है। दैट इज इम्पोर्टेंट इन योर सेशन। तो ये मतलब पूरा सिलेबस तो यही था। अभी भी हमारे पास क्लासेस लेफ्ट हैं। वी विल गो
हाँ है।
थ्रू ईच ऑफ द सेक्शंस। अभी जो हमारे वैसे तो हमने सारे कवर अप कर लिए हैं ब्लॉक्स, बेसिकली, सॉरी, ब्लॉक्स तो हमने कवर अप कर लिए हैं, बट वन वन मोर टाइम विल जस्ट सी कि समथिंग विच आप भी अगर निकाल सको, विच यू आर नॉट एबल टू अंडरस्टैंड, या ऐसा कुछ है जो हम डिस्कस कर सकते हैं और भी, तो नेक्स्ट क्लासेस में वो चीजें हम डिस्कस करेंगे ब्लॉक्स में से देख के कि क्या चीज अभी भी समझ में नहीं आई, राइट।
यस मैम।
डायग्राम्स तो मैंने मोस्ट ऑफ द टाइम आपको सारे बता ही दिए हैं,
हाँ डायग्राम तो होगा।
बट फिर भी अगर किसी को अभी भी कोई डायग्राम में प्रॉब्लम है या कोई डायग्राम अभी भी जानना है, तो वी कैन गो फॉर दैट। जैसे यहाँ पे देखो इन्होंने जो रेफरेंस दिए हुए हैं, कैन यू सी दैट रेफरेंसेस।
यस यस
ये
यस।
वैसे तो ब्रैडी बूच की पियर्सन की बुक है
हाँ हाँ।
यूनिफाइड मॉडलिंग लैंग्वेज के ऊपर, बट ये बुक है। बाकी ये आपका जो यूएमएल, एग्रो
सॉफ्टवेयर
यूएमएल करके एक सॉफ्टवेयर है,
आर्गो।
उसका लिंक दिया हुआ है। ये आपका स्टार यूएमएल का सॉफ्टवेयर का दिया हुआ है। डॉक्यूमेंट भी दिए हुए हैं, डॉक मतलब उसके अगर आपको पढ़ने हो तो। उसके अलावा बीओ यूएमएल का दिया हुआ है, ये एक और सॉफ्टवेयर है। और ये विकिपीडिया का लिंक दिया हुआ है यूनिफाइड मॉडलिंग लैंग्वेज के लिए। ये uml.org, यूएमएल डायग्राम्स के बारे में जो भी इंफॉर्मेशन है वो उसके दिए हुए हैं लिंक्स, अगर आपको पढ़ने हो तो इन्होंने रेफरेंस भी दिए हुए हैं कुछ कुछ, तो आप जाके उनको पढ़ सकते हैं, राइट। सो कोई डाउट है अभी तक, वट एवर वी हैव स्टार्टेड, जो भी हमने किया है?
नो मैडम, इसमें तो कोई डाउट फिलहाल नहीं है अभी तक।
वैसे तो सिंपल है, मुझे नहीं लगता
हाँ
कि
ऐसा ठीक है।
कोई प्रॉब्लम आगे भी आने वाली है आपको। इट्स अ सिंपल सब्जेक्ट, ऐसा कुछ दिक्कत वाला सब्जेक्ट नहीं है, ये पास होना बहुत आसान है इसमें।
थोड़ा सा प्रैक्टिस चाहिए, फिर हो जाएगा इसमें।
प्रैक्टिस
एक दो
डायग्राम के ऊपर चाहिए। बाकी
हाँ
तो
जी।
अगर आपको प्रोसेस का पता है कि ये चीज किस तरह मतलब आपको दिखानी है, जैसे क्लास डायग्राम किसी प्रोसेस का कैसे दिखाना है या यूज केस कैसे दिखाना है, तो अगर आपको ड्रॉ करना आता है तो कोई दिक्कत नहीं होगी,
राइट मैम, राइट।
राइट। तो आपको ड्राइंग के लिए आपको कंपोनेंट्स पता होने चाहिए हर डायग्राम के। वो चाहे क्लास डायग्राम हो चाहे यूज केस डायग्राम हो, क्योंकि आप यूज केस डायग्राम में इंक्लूड और एक्सटेंड वाला अगर नहीं समझ पाए हैं तो इंक्लूड और एक्सटेंड को हम नेक्स्ट क्लास में समझ सकते हैं, जो
यस मैम।
डिपेंडेंसीज है। ठीक है, तो ऐसे कुछ कुछ चीजें हैं जो आपको नहीं समझ में आई हैं, तो वी कैन डिस्कस इन द क्लासेस कमिंग, जो नेक्स्ट क्लासेस आएंगी उनमें हम उन चीजों को
श्योर।
डिटेल में देख सकते
जी मैम। एक बार पूछा था मैम,
हैं,
जैसे
राइट।
जो वेब टेक्नोलॉजी का हमारा एक है सब्जेक्ट, तो उसकी भी लैब्स वगैरह होंगी क्या?
आपका होगा ना उसमें, क्या नाम है, सेशन में नहीं है?
है तो मेंशन तो है, आई थिंक कि इसी के साथ ही इंक्लूड है, मतलब पहले ही जैसे आपने करा दिया सेशन कंप्लीट, पूरे ब्लॉक्स करा दिए।
नहीं नहीं नहीं,
एक
आपके कितने सेशंस हैं, ये MCSL 222 के कितने सेशंस हैं?
ये मैम आई थिंक नवंबर एंड तक ही है।
30 नवंबर तक जा रहे हैं।
हाँ
नहीं
जी,
नहीं,
नवंबर।
एक तो देखो मेरा मेरा जो है ना, मैं एक मिनट देखती हूँ।
मैडम एक 16 को तो हो गया, अभी 22 नवंबर है, 23 नवंबर
देखो
है
मेरा
फिर।
मेरा तो मुझे पता है,
इसमें
मैं डेट शीट की बात नहीं कर रही हूँ, एक्चुअली दो सेक्शंस है ना आपके।
हाँ जी, हाँ जी।
तो कोई और टीचर नहीं करा रहा है क्या वेब टेक्नोलॉजी?
आपके
मैडम
नाम है।
सेक्शन 1 ही लिखे हुए हैं MCSL 222 के।
सेक्शन 1 ही लिखा है, सेक्शन 2 लिखा ही नहीं है।
नहीं मैडम, सेक्शन 1 ही लिखा है। आप ये देखिए 16 नवंबर में सेक्शन 1 सेशन 6 है, फिर 22 नवंबर में सेक्शन 1 सेशन 7 है, फिर
तो ये
ट्वेंटी
तो
थ्री
मुझे,
नवंबर में
आई हैव नो आइडिया
सेक्शन
अबाउट
वन
दैट, क्योंकि वेब
सेशन 8।
टेक्नोलॉजी मैंने कराया नहीं है कभी, तो आई हैव
तो
नो आइडिया
9-10
अबाउट
तक
दैट।
जा रहे हैं इसके सेशंस। इसके 10 सेशंस है, ये 6 सेशन था जो आज आपने
और
पढ़ाया होगा।
MCSL 2 का सेक्शन 2 कहीं नहीं मेंशन है आपके उसमें?
नहीं मैडम, सेक्शन 1 ही मेंशन्ड है बस।
तो सेक्शन 1 तो OAD ही है, मुझे तो यही पता है। सेक्शन 2 का आई हैव नो आइडिया, आई हैव
सेक्शन
टू
टू
आस्क। I have to ask the persons in merit कि
सेक्शन
उसका
2
क्या
तो
करा रहे हैं।
कहीं
सेक्शन 2
नहीं
तो
है।
कहीं मेंशन होना चाहिए।
हाँ जी, हाँ जी, मैं इसलिए पूछा था क्योंकि अभी जैसे हमारा ये वो
हम्म,
लेगा नेक्स्ट सेशन
मुझे
के बाद
बिल्कुल
आप
आइडिया नहीं है। मुझे बिल्कुल आइडिया
सेक्शन
नहीं है।
2 जो है 223 में था, वो 1 नवंबर को सर ने
नहीं, वो तो
कराया था।
223 है ना, वो तो सेपरेट है ना, वो दूसरा
टू
कोड है।
टू
दूसरे कोड में भी
ट्रिपल
दो
टू में
सेक्शंस हैं।
ट्रिपल टू में
दूसरे
सिर्फ
कोड में
एक
भी दो
दिया हुआ
सेक्शन है।
है।
उसमें दो सेक्शन का अलग अलग है प्रैक्टिकल। ट्रिप टू
यस
टू
यस।
थ्री में टू
पर टू
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 टू का एक ही सेक्शन दिया हुआ है इसमें।
टू टू थ्री का दो दिए हुए हैं।
हाँ,
तो ये मुझे बात करनी पड़ेगी, मुझे खुद नहीं पता है कि वेब टेक्नोलॉजी में उन्होंने क्यों नहीं
टू टू
मेंशन
थ्री
किया।
में मैडम 223 में सेक्शन 1 नहीं है हमारे पास, सेक्शन 2 ही दिया हुआ है बस।
सेक्शन 1 नहीं है?
नहीं,
ऐसा कैसे हो सकता है? ये कैसा वो बना है शेड्यूल?
एक मिनट आप रुको, मैं आपको।
मेरे पास पूरा शेड्यूल नहीं है आपका, मेरे पास मेरा ही शेड्यूल आया है, इसलिए मुझे पता नहीं है, इसलिए आई एम आस्किंग।
नहीं, मैं एक मिनट में अभी जो है इसको दिखा देता हूँ आपको। आप एक मिनट रुक
ऐसा
जाओ
कैसे
इसको
हो
भी।
सकता है? क्योंकि 223 में तो आपके वो है ना, नेटवर्किंग सेक्शन 1 है, और सेक्शन 2 शायद वो है क्या नाम है उसका?
जावा का वेब वेब वाला
नहीं,
वेब
वेब
टेक्नोलॉजी।
वाला तो मेरे वाले में है ना। टू टू
हाँ
थ्री
जी,
की
हाँ
बात
जी।
कर रही हूँ। 223 में तो
हाँ,
नेटवर्किंग है, और
उसमें मैं नेटवर्किंग का ही
डेटा
है।
साइंस है। डेटा साइंस है, क्या है
डेटा
सेकंड?
माइनिंग।
डेटा माइनिंग है, हाँ डेटा माइनिंग है सेकंड सेक्शन।
मैं
प्रॉबेबली
स्क्रीन
मुझे,
शेयर करूँ?
हाँ कर लो कर लो। मुझे पूछना पड़ेगा मेरिट में ना, आई डोंट हैव एनी आइडिया कि उन्होंने क्या कैसे शेड्यूल बनाया है।
ये शेड्यूल है जो आपके स्क्रीन पे, आप मेरे स्क्रीन पे देख पा रहे हो आप।
हाँ मेरे को दिख रहा
और
है।
इस शेड्यूल में आप ये देखिए कि ये जो है हमारे उसमें 223 यहाँ से शुरू हो रहा है, 222 भी यहीं से शुरू हो रहा है। और इसमें जो है
सेक्शन 2 मेंशन ही नहीं है।
देखिए 223 सेक्शन 2, 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 सब जगह यहाँ पे से 16 नवंबर से सेक्शन 1 223 में आया, यहाँ पे से आया, लेकिन 222 में सेक्शन 1 ही चल रहा है।
हाँ सेक्शन 2 है ही
लास्ट
नहीं।
नहीं है, सिर्फ सेक्शन 1 ही चल रहा है उसमें।
तो मुझे उनसे बात करनी पड़ेगी, आई हैव नो आइडिया अबाउट दैट।
यही है। क्लोज कर दूं?
अब से हाँ कर दीजिए सेक्शन 1, क्योंकि सेक्शन 1 तो मुझे पता है, सेक्शन 1 इज ऑब्जेक्ट ओरिएंटेड एनालिसिस एंड डिजाइन जो हम कर रहे हैं।
यस।
सेक्शन 2 इज योर वेब टेक्नोलॉजीज, सो
हाँ,
वो
सेक्शन 2
तो,
वेब टेक्नोलॉजीज।
हाँ तो वेब टेक्नोलॉजीज तो मेंशन होना चाहिए था, कोई और फैकल्टी को कराना चाहिए था।
लास्ट टाइम भी मेरे ख्याल से उसमें एक सेक्शन का प्रैक्टिकल में नहीं था ऐसा कुछ।
हाँ, लास्ट टाइम भी ऐसे ही
हाँ
हो गया।
लास्ट टाइम। अच्छा
नहीं, एक
लास्ट टाइम
सेक्शन
कब?
था,
फर्स्ट
उसमें भी एक ही सेक्शन था।
लास्ट टाइम कब?
फर्स्ट सेमेस्टर
फर्स्ट
में।
सेमेस्टर में?
फर्स्ट
किस
सेमेस्टर।
वाली का? फर्स्ट
यस
सेमेस्टर
यस।
में आपका 217 तो एक ही प्रैक्टिकल है, सॉफ्टवेयर इंजीनियरिंग, उसमें दो सेक्शन नहीं है। 216 जो है उसमें दो होते हैं, डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम, और सेकंड सेक्शन होता है वो इसका वेब 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 डिजाइन का।
हाँ, तो उसमें भी हमको एक ही पढ़ा था हमने, उसमें दूसरा नहीं पढ़ा था हमने।
डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम पढ़ा था क्या?
हाँ जी, हाँ जी, वही पढ़ा
थ्योरी
था
में
बस।
तो पढ़ा था उसमें, लेकिन प्रैक्टिकल में हमने एक ही पढ़ा था, दो सेक्शन थे, एक ही सेक्शन पढ़ा था
प्रैक्टिकल
हमने।
में डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम ही पढ़ा था, वेब पेज नहीं पढ़ा था।
वेब पेज नहीं पढ़ा था मैं।
वेब पेज
हम्म,
नहीं पढ़ा था, हाँ राइट।
हम्म। मैं बात करती हूँ, मुझे खुद आइडिया नहीं है
राइट।
राइट व्हाट दे हैव डन।
हाँ, मतलब बस पॉइंट था मैम, क्योंकि फिर ये इस बार ना हो
वेब
जाए।
टेक्नोलॉजीज थ्योरी में तो है ना आपका? थ्योरी
हाँ
में तो
जी,
पढ़ाया गया ना?
हाँ जी मैम।
हाँ हाँ।
हाँ ठीक है, मैं बात करती हूँ, आई हैव नो आइडिया कि क्या हुआ है, तो प्रोबेबली नेक्स्ट क्लास में आपको इंफॉर्मेशन आई जाएगी क्या सिचुएशन है फिर उस चीज की।
ठीक है।
राइट, मैं बात करती हूँ मेरिट में, राइट,
ओके मैम।
राइट।
कि क्या है उसका। बाकी आपका ये सारा कवर अप सबने अपना क्वेश्चंस रख दिया है?
Yes, मैम डाल
Name
दिया.
and name and enrollment number in the chat box. Everybody
हाँ
who
मैडम
has
डाल
not put. अगर क्लास के
दिया.
शुरू में डाल दिया है, it's not a problem. आपको दोबारा डालने की जरूरत नहीं है. जिन्होंने नहीं डाला है अभी तक, वो प्लीज डाल दीजिए. So we'll end the class. और तो कोई डाउट नहीं है.
नो मैडम.
तो ये मैं पता कर लेती हूँ. आपको इंफॉर्मेशन पता लग जाएगी जो भी होगा. राइट, इसके बारे में.
राइट.
तो मैं अटेंडेंस तो नोट कर ली है.
तो मैम वैसे नेक्स्ट क्लास में आप आएंगे क्या पढ़ाने?
मेरे अगर मुझे क्लास दी है तो मुझे तो आना ही है ना.
हाँ जी, हाँ जी,
नाम तो अलॉटेड है तो मुझे तो आना ही है.
श्योर मैम, श्योर.
हाँ,
शेड्यूल अभी में आपका
बाकी
नाम.
वो शेड्यूल में क्या चेंज करेंगे मैं कह नहीं सकती. अभी तक तो मेरा नाम है तो मुझे आना ही है.
यस.
हाँ, बाकी मैं देख लेती हूँ. If probably they'll tell me to take that class, so I'll see कि मैं क्या कर सकती हूँ. I have never gone through that thing. हाँ, अगर पाइथन वाइथन कुछ और होता या डेटा माइनिंग होता या आर प्रोग्रामिंग होता, पाइथन होता या वो, तो मैं करवा सकती थी. बट आई हैव नेवर गॉन थ्रू दैट वेब टेक्नोलॉजीज. बट लेट मी सी, आई विल फाइंड आउट व्हाट टू डू इफ दे टेल मी टू डू दैट. राइट.
ऑलराइट मैम.
तो 4 क्लासेस में हम कितना कवर अप कर पाते हैं, विल टेक सी टू दैट. ठीक है, हमारा ये वाला सिलेबस तो हो गया है. इसमें तो कोई दिक्कत है नहीं है.
हाँ
बाकी
जी,
वो
ये तो
4
हो गया.
क्लासेस में, हाँ 4 क्लासेस में हम क्या करते हैं, लेट अस सी. राइट.
यस मैम.
Okay then, take care. We'll meet in
ओके.
the next class, that is next Saturday.
थैंक यू मैडम. गुड बाय. हैव अ गुड डे.
Thanks. Take care.